this is how we created an interactive LED corner experience. So we have two 2D lidars right there up above each screen. So they are scanning in front of the screen and they emit an invisible infrared light, right? And we have another one, 3D LiDAR over there. And this one is scanning the space around us and it's creating a point cloud. And in that point cloud, we define a surface. So right now we define the floor. And we're able with our algorithm to project on that surface the point cloud, and anything moving in the point cloud on that surface becomes a blob, and we can give it X, Y coordinates. So the same for the 2D and the 3D, we will convert all its metric data into pixel coordinates because we work in pixels, right, to display in the end. Here we have interactive particle system, so we collide with particles. Right here we have an 1152 per 1152 square walls and 640 on the floor. Since we're talking now into pixels, we can define zones in the pixel area and create these zones to be interactive. So that creates buttons basically, right? And when we cut the beam at that precise point, we know there's an interaction and we can launch a number of show control tasks that will do stuff in the shows. Here we have a living art demo where you can see that all these art pieces are cycling through sort of loops, right? And when we interact with them, they're gonna start launching text, random text. We have 3 random lines for every art piece. And another interaction that we added on them is if you step close to it, you get this effect on the wall that when you walk towards an art piece, it lights up. And if you interact with it, it starts speaking. Now, there's another thing that's being showcased here is the segment mode. That's why we call it living art. They're living because they're in this endless 2-second loop. And when you interact with them, they're gonna move on to the next segment. That's the part where they talk. So we have that floor effect under your feet. Here we're having 2 still images that are being composited one on top of each other. And our blobs are just large soft-edged circles. It gives a crazy cool effect because it's just the same media with 2 different colors. And we just move around and reveal one under the other. It's just, everything is done in one box in Modulo Kinetic. We integrated a 3D physics engine inside Modulo Kinetic, so we can calculate real-time physics. Right now what we're looking at is a composition of some 2D background, but we're looking at a 3D scene because the real-time physics engine works with the 3D scene. So we have both the 3D engine and the 3D physics. We have a knockdown game, and I invite you to knock down some of the cans on this wall by throwing the ball. Boom, real-time physics. Impossible to calculate, this is not pre-rendered. And the last one probably over here. Victory condition has been achieved, and now we got these, and the game is just basically gonna reset. On the floor here, we have a trailing effect. So we added a built-in node that calculates trailing. So it follows the movement of someone going around. The 3D engine, you're gonna see on this next demo, which is the car. The 3D engine enables us to display real 3D models with real lighting and real materials that react to the lighting. Real lighting, as I was saying, we're just giving some emission on those headlights over there. We've got some lights on the inside that we can turn on as well. Maybe change the color of some materials. And I was saying we were looking at a 3D model because we can move the camera and target camera position and just look at a different angle. Now the really cool thing with this demo is we've added the support for us to be able to correlate the 2D data of where we're touching in the 2D space into are we touching an object or not through the camera view. So if I come here and touch the trunk, I can detect that I am touching the trunk and launch the trunk animation. Same for the front door, for example. These animations come from within the model itself, but to prove to you that I'm actually touching the model and it's not just an interactive zone, I'm gonna change the view, and to close them, nothing's gonna happen if I touch here. I have to touch the door and I have to touch the trunk. Now that can be very useful in interactive scenarios. Here we have another example of a reveal. This one shows that first we're using another type of effect, sort of fluid effect for the reveal. We're running a movie, and what we're looking at is the floor of the scene, right, with the material. So the last demo we have here, we're gonna find this new fluid, that fluid effect that we had on the reveal. We have it this time, we're drawing with it on the floor. And what's really cool with the 3D LiDAR is it's scalable. I mean, we could be 20 on stage and everybody would have their own circles. And then when you leave the stage, the circle leaves with you. It just follows everyone around. You could even collide with people and it kind of sort of changes the color. If we collide there, you see I was red and then I became like pink. And here we have a simple video launcher. Now this one works really well in just like live events or expositions, just to show some it's interactive, of course, so anybody could come and interact. It would launch a video. So this could be useful in lots of different scenarios. And all of this is generated inside the box. These effects are generated inside the box. Even what you're looking at in the background is a generated effect inside the box. That's a very handy tool for creative operators. Like if something's missing and they want to add a little more into the show, they have all the tools from within. They don't have to call creative guys that are gonna rendering hours and send the files and everything. And then moving back down to the menu, I think we went through all 4 of these demos, and there you have it.